12.2 continues the discussion of factoring, but looks specifically at factoring trinomials. So remember, that was when I was working with a polynomial that has 3 terms, maybe like an x squared plus a bx plus a c. So here's an example. We're going to look at how we factor that. So here's what we do. So we think of this as an x squared plus a bx plus a c. So here's the b, here's the c. So I'm going to follow this rule. So I need to look for numbers that add up to 7 and multiply to 12. So typically what we do is we start with the product and we start thinking about factors of 12. Then we have to look for the pair that's going to add up to 7. So it looks like 4 and 3. I can check that. Let's see. 4 plus 3 is 7. 4 times 3 is 12. So those are the correct numbers. So I can go ahead and write out my factorization. And the nice thing with these is I can actually check them just by doing the FOIL. Be x squared plus 3x plus 4x plus 12. So x squared plus 7x plus 12. So indeed, that checks. Okay, let's try another one. So I need to find numbers that add to negative 11 and multiply to positive 24. So I look at the product, factors of 24, okay, I'm thinking 8 and 3, except you have to be careful because here the sum needs to be negative. So actually, what if I put negatives in front of both of these? Because then, let me see, negative 8 plus negative 3 would be negative 11. Negative 8 times negative 3 would be positive 24. So actually, my factorization is p minus 8 times p minus 3. To check that with the FOIL, combine those like terms and looks good. How about number 3? Okay, my numbers need to add up to 3, multiply to negative 28. So I start looking at factors of 28. I'll look at the sign here in a minute. Let's see, 14 and 2. 7 and 4 look like they're going to work. But let's see. The product is negative, so that means one of those factors has to be negative, right? One negative and one positive. So let me see. If I make that one negative, does that work? 7 plus negative 4 is 3. 7 times negative 4 is negative 28. So that's my pair. So let me write in my factorization. can check that with a quick FOIL. Let's see, that'd be z squared minus 4z plus 7z minus 28, z squared plus 3z minus 28. And that's what I started with. Looks good. Okay, number 4. M plus n has to be negative 7. M times n has to be negative 18. I look at the product. Let's see, 18 and 1, 9 and 2, I think will work. So again, I need one negative, right? Because the product is negative. So what about this pair? Let's try it. Negative 9 plus 2 is negative 7. Negative 9 times 2 is negative 18. Okay, so that's my pair. Just write out the factors. So a minus 9, a plus 2. I'll let you check that one on your own. All right, number 5. M plus n is 10. M times n is 12. Look at the product. Factors of 12. 12 and 1, 4 and 3, and 6 and 2, and I think that's it. So let's see. If I add these, I get 13. If I add these, I get 8. If I add these, I get 7. So none of those pairs gives me the 10. Okay, so actually here, none of the pairs work. None of the pairs yield the correct sum of 10. And so in that case, I'm actually going to conclude that this trinomial is prime. So what that means it can't be factored. So I just have to make sure that I've exhausted all the possibilities for factors here before I make that conclusion, right? But I think those are the only factors of 12. Oops. Okay, what about number 6? So adds to negative 8, multiplies to negative 9. I look at the product, 9 and 1, 3 and 3. So let's see, since I have an 8, I'm thinking something with 9 and 1. My product is negative, so one of my special numbers here has to be negative. How about that one? Does that work? Negative 9 plus 1 is negative 8. Negative 9 times 1 is negative 9. So that looks good. That'd be y minus 9, y plus 1. Okay, so if we did a little check, let's see, foiling that, be y squared plus y minus 9y minus 9. Combine the 1y minus the 9y minus 8y minus 9. Looks correct. Okay, here's an interesting one because you see how I have the variable y in there? So I'm still factoring this in x. I'm kind of thinking of this, if you rearrange this, you can think of the y there as actually being part of the coefficient. So I would do the same process, but I'd look for numbers that add up to 4y. Multiply to negative 21y squared. So again, I look at this, and I'm kind of just looking at the number first. So let me see, 21 and 1, I think 7 and 3 are going to give me my 4. So I need a negative, right? Let's see, which one is it? This one. But then I have to add the y's in there. So let me see if this works. So 7y plus negative 3y is 4y. 7y times negative 3y is negative 21y squared. So indeed, those are my numbers. So positive 7y, negative 3y. I'm doing a little check on that. Let's see, it'd be x squared minus 3xy plus 7xy minus 21y squared. X squared plus 4xy minus 21y squared. Looks great. Here's another one. It's very similar. So again, I'd maybe rearrange just so you can see you're thinking of that y as being part of that coefficient. So my numbers add to negative 14y, multiply to 24y squared. I look at the product. Let's see, 24 and 1, 12, 12 and 2 are going to work. But this is positive, the sum is negative, so both of these are going to be negative. Don't forget to put that y in there. Let me check. That looks good. And that looks good. Write in my factors. And I'll let you check that one by foiling it on your own. Okay, this is very similar, except this one uses the letters M and N. So I would, again, I'm thinking of this as like the M is the variable, 16N here is the coefficient. Let's use different letters here then. A plus B is 16N. A times B is 18N squared. I start by looking at the product. Let's just look at the number first. 18 and 1, 9 and 2, 6 and 3. Are those the only numbers that multiply to 18? Let's see, that'd be 9 times 2, 3 times 6, so yes. So let me see, that'd be 19, that'd be 18 wait a minute, that'd be 19, that'd be 11. I'm doing the sum. 19, 11, 9. So none of those give me the 16. So actually, in this case, I would conclude again that this trinomial is prime. It actually can't be factored. So what's special about number 10? So the first thing I notice about number 10 is that actually there's a greatest common factor. So remember, if I have a greatest common factor, I can actually take that out of the whole expression. So I would start by pulling that greatest common factor out. I should always look for that first if it exists. Okay, then I just leave the 5 in front and I look at my trinomial. Let's do it this way actually. So in other words, I'm going to factor that trinomial, same as we've been doing. So let's see, add to 6, multiply to 8. Let's see, 4 and 2, right? It's an easy one. So I could check that. I mean, first I would do the FOIL. So let's see, it'd be x squared plus 2x plus 4x, so plus 6x plus 8. Then I would distribute the 5. 5x squared plus 30x plus 40. Here's another one that has a GCF, -3. So the first thing I would do is take that -3 out of the whole expression. So I leave that -3 there in front, that GCF. And I go ahead and look for numbers that add to 8 and multiply to 16. Let's see, multiply to 16. Oh, 4 and 4, huh? Those add to 8 and multiply to 16. Okay, so plus 4 and plus 4. Oh, so this one, here's something kind of cool. This one, you see how I have x plus 4 times itself, x plus 4 times x plus 4. So actually here I can go one more step. I can make that x plus 4 squared. Okay, so I'll let you check that one on your own. Couple more, let's see, 3 more. So this one I would probably start by rearranging it, putting it in standard form. So remember, I would do that by putting the terms in order, by decreasing exponents. And then again, I always look first for that greatest common factor. Actually, I can take an x out of this whole expression. So I go ahead and pull that out. Then I just leave that in front. And I go ahead and factor the trinomial inside. So m plus n is 10. M times n is negative 75. So I've got to look at 75 to start out with. So 75 and 1, 25 and 3, 5 and 15, I guess. That pair is going to work because I'm looking for a 10. But you see how this product is negative? So one of my numbers is negative. So if I do this pair, let's see, the 5 has to be negative, right? So that way, let's see, negative 5 plus 15 is 10. Negative 5 times 15 is negative 75. Okay? So then let's see, what is it? It's negative 5, positive 15. Maybe I'll want to move these down a little bit. Let's try that. So this is kind of a funky one because actually here, in order to get that x squared y squared, don't we actually need an xy in each of our factors? Because when we multiply the xy and the xy, can rearrange that, right? That's the x squared y squared. So then let me see, looking at my numbers, they need to add up to 3 and multiply to 2. Well, 2 and 1 work, right? So what if I try putting 2 and 1 here? Let's see if that works. So then let's check that. So that's the x squared y squared. 1xy, 2xy, and 2. Oh, look at that. Get back what I started with. So that's right. That one requires a little creative thinking, I guess, huh? Does check. And finally our last one. Okay, let's see. I notice a couple things. I notice I have 4 terms. So remember, when I see 4 terms, I think probably want to try grouping. Okay, what else? Then I notice that I want to look first for a GCF, greatest common factor. I think everything's divisible by 3 and also an A. So I want to start by taking that greatest common factor out. Check as you go. 3a to the 4th minus 12a cubed minus 6a squared plus 24a. So it looks good so far. Then continue. So remember, with factoring by grouping, I look at the first group. So let's see, from that green group, I can take out an a squared. That'd leave me with an a minus a 4, because that'd be a cubed minus 4a squared. Okay, from the red group, I can take out a negative 2. That'd leave me an a minus a 4, because that'd be negative 2a plus 8. Okay, then I notice, of course, that I have this GCF overall. So now I take that a minus 4 out, and I'm left with a squared minus 2. You can think about distributing this. Let's see, I'd have my 3a, and then I'd have a squared times the a minus 4, and then minus 2 times the a minus 4. That's what I had here, right? Then if you continue, you can check the result entirely, but I'll leave that part up to you. There's my answer.